I remember when I was taking calculus, this was one of my favorite integrals. So I thought I would show you, and maybe you would find it interesting as well. It doesn't look so interesting just from the beginning. We have e to the x times cosine of x dx. So we're going to try to integrate this. And the way I'm going to evaluate it is I'm going to think of e to the x as a function and cosine as a different function. So I'm going to think of this as just two functions being multiplied together. So it's kind of like f times g dx. That's what I'm going to think of. So I'm going to think of it as multiplied, okay? If we do that, if we think of it in that way, then we can use the formula that's derived by parts. So we can say that u dv equals uv minus v du. Okay, we can think about it in that way. So this is the by parts formula that we can use, and this will integrate it for us. So the tricky thing about this is, what do you pick for which piece? So you have u dv, you have to make a choice about those, and then by that choice, this will come out, okay? So we need to make a choice of what is going to be our u. It's like substitution, but it's a little bit more complicated. And this particular example is a bit more complicated. So let's take a look. I'm going to choose, let's do e to the x as u, okay? Now I'm gonna take the derivative of u. So du dx still just equals e to the x. If you remember that e to the x is its own derivative. In fact, that's one of the ways it's defined. Okay, so I picked my u. There it is. I take the derivative. There it is. So that means that du, which I need for the formula, is e to the x dx. Okay, well, hopefully that works out. Next choice is I have to figure out what am I going to choose for my dv. So I'm going to choose cosine. So I'm going to choose dv equals cosine x, okay, dx. All right. Now I'm going to integrate this. Okay, I'm going to integrate both sides to find v. All right, well, the derivative of sine is cosine, so that was easy enough. So v then equals sine of x. Okay, so I've made my choices, and then now I just need to plug this in the formula and see what happens. Okay, but things are starting to get messy on my paper, so I'm just going to get a fresh sheet, and we're just going to build it. So we'll start from the beginning, as if we knew exactly what we're doing from the top, right? So, okay, we're going to say that this equals this formula. Okay, well, what is that formula? We have uv. What did we pick for our u? E to the x. What did we get for v? We got sine x. Okay, and then from there, we want to integrate v, which is sine x, and then times du. What was our du? It was e to the x dx. All right. Well, that's kind of strange because we have another situation here. We have sine of the x times e to the x. It's pretty much the same thing all over again, except now we have sine x instead of cosine x. So I gotta do it again. Okay, so u equals e to the x, du dx. That's kind of just the exact same thing, so we'll just write that. All right, well, what am I going to pick for my dv? I'm just going to pick sine of x. Hopefully it works out. All right, and that would be dx. And the derivative of cosine is negative sine, so v must equal negative cosine x. That must be true. All right, I'm going to have to do this whole thing by parts again. All right, that's kind of messy, but That's the way it is. Alright, so here we go. E to the x sine x minus, alright, now uv, alright, that's minus e to the x cosine x, then minus the integral of our v, which is negative cosine x, and then du is times e to the x dx. Oh my goodness. Okay. Well, what's going on here? One thing is, I can just make that positive. That's one thing I need to fix. So this would become positive, and then I also notice that here we have this becomes positive. So I'm just going to rewrite this and try to clean it up a little bit. E to the x sine x plus e to the x cosine x. And that becomes positive, but then this negative here makes it negative, so we're over here now. Cos x e to the x dx. Alright, let's just do a quick sanity check and see what it is we've even done here. Okay, so what have we done? We've said that e to the x cosine x dx equals this thing. Well, it spit itself out. And that was one thing that when I first saw this result, it blew my mind. And it's just happening because, well, that's just it. E to the x is its own derivative, and cosine is a periodic function, and so, if we take the derivative of it, we're getting it back. Okay, but it's still pretty wild, right? We think when we do an integral, we're just going to get, a solution and that's it, but it spit itself out. Okay, that's kind of weird. So now we have this integral on both sides. Well, if that's true, then just by algebra, I can put them together and we just say we have two of them. So that becomes 2 of the integral e to the x cosine x dx equals e to the x sine x plus e to the x cosine x. Right? That's pretty strange, I would say. I mean, most integrals, certainly in the intro, we would just, we just have some function come out. But this seems to be kind of reciprocal, all right? It's spitting itself out. Now we have 2 of these. So what I'm going to do is I'm just going to divide both sides by 2 as if, it's just a variable. And so by doing that, I'm going to say, well, e to the x cosine x dx must equal e to the x sine x plus e to the x cosine x over 2 integration constant. Okay, that's pretty wild. I mean, at least it was the first time I saw it, that you would do an integral and it would come out of itself. That was something, I still remember that feeling of just bafflement, the way that happened. Okay, so we have that integration constant we can't forget, but I really liked that integral when I first saw it, so I thought maybe you'd get a kick out of it too. Alright, hopefully that helps.